So, took the derivative. Is that 1 minus 4/3 x to the minus 1/3?
Yep.
Okay. And then you're going to set that whole thing equal to 0.
Yep.
I'm not sure I necessarily would have written that with a radical sign, just because it's too easy to misinterpret.
Okay.
In other words, I can see there's a tiny little 3 there, but if I didn't know better, I wouldn't necessarily know it.
Okay.
And then, so you move the 1 on the other side, multiply both sides by x to the 3rd, and multiply both sides by minus 3. Okay. So you get, so we get x. Okay, you got it up here. You get x to the 1/3 equals minus 4/3 cubits. What's wrong with that answer?
No idea.
Well, if you cube a negative number, it stays negative. So the fact that I don't see a minus 64/27 on here means we must have a sign wrong somewhere. Let's go back over that. So that's 1 minus 4/3 x to the minus 1/3 equals 0. Notice that if I make it minus 4/3 x to the minus 1/3 equals negative 1, multiplied by the reciprocal, I get x to the minus 1/3 equals 3/4, positive 3/4. Don't I? Yeah, if I multiply both sides by minus 3/4, and that gets rid of that coefficient and turns that to a positive sign. So now I got 1 over x to the 1/3 equals 3/4. And now if I move that to the right side, I got x to the 1/3 equals 4/3. Now when I cube it, I get 64/27. And you did the right thing here, is choosing that, even though the way you came up with it, that's a negative sign right there, isn't it?
Yeah, I know. I don't know how I got a negative, but I figured I just did something wrong with the signs.
Well, that's a good way to look at it. That's what I would have done also. Rather, especially if this is a timed test, I'm not even sure I would have gone back and tried to figure out where my mistake was. I would have completed probably the rest of the test first and then gone back and looked at number 1. Would have been my strategy, I think. Because the problem with getting a sign wrong is you might get more than the sign wrong. Although, notice that none of these answers are a fraction cubed. In other words, there's no way 16 over 9 could be anything cubed. Not integers, at least. Same thing with 4 over 3 or 2 or 4. The only thing that even looks like it's cubed is 64 over 27. So that'd be another way to kind of look at the problem. All right, what's the minimum value of, leave out the F there, did she? He? Yeah, notice he has quite a few typos in his stuff. You see the F that's missing?
Uh-huh.
It's probably because of the of. There's actually a pretty interesting phenomenon with the word OF. I've got a little index. Well, I'll tell you about that later. But people don't see the F. When you give them a piece of paper that has the word OF on it and you say how many F's are on the paper, because they pronounce it of, they don't see the F. And it's amazing. 9 people out of 10 are like that. They will not see the F. So anyway, we have f of x equal x squared ln x. So you took the derivative of it, and you got x squared over x.
Yeah, that was just an answer, but I had no idea what to do.
I'm sorry, what?
I had no idea like how to solve the equation. Like I know I set it equal to 0, but like what do I do from there?
Okay, well, first of all, x squared over x turns into just x. So we have x plus 2x natural log of x equals 0. So if I factor in other words, when you have the sum of a couple of things equal to 0, if you can turn that into the product of two things equal to 0, then you're much better off. See, that's what I'm doing when I factor, is I'm turning it into the product of two things. Now I can say that either x is 0 or that is 0. And I can solve that.
Okay.
Now let's talk about solving it. So one solution is x equals 0. Problem with x equals 0 is it violates this domain. So x cannot be equal to 0 because you cannot take the natural log of 0. So this solution is not valid, but it certainly is one of the first solutions we come up with. And then we go back and test it. Then the other one is going to be 1 plus 2 natural log of x equals 0. So natural log of x equals minus 1/2. And how do I solve that?
I don't know.
It's a rather... Actually, the way to solve it is there's two ways. There's the way that's a little bit out of the box that you have to kind of get used to using before you even see it as a way. But better yet, it's in logarithmic expression right now. Turn that into exponential expression.
Would it be 1/2?
No. Start with the base. So it's e to the negative 1/2 equals x. That's how you turn that into an exponential expression. Is you take the base, logs are exponents, so this minus 1/2 has to be an exponent. So you take the base, which is e, to the minus 1/2 power, and that's equal to the argument. And that is...
Wait, so why wouldn't it be d then?
Well, hold on a minute. Because that would be 1 over the square root of e. But where's the minus sign coming from? Oh, I see what happened. Our premise was wrong. Let's go back and differentiate this. We didn't differentiate it right. Or did we? Yes, we did. Got x squared times the derivative of log of x, which is that, plus 2x natural log of x. That becomes that. We set it equal to 0. Factor out x becomes 1 plus 2 natural log of x equals 0. This cannot be 0. So this has to be 0. So I get 1 plus 2 natural log of x equals 0. So I get natural log of x equals minus 1/2. And then this is the other way to do it, where you make that the exponent of e on the left and the right side of the equation, and then that turns into x. So you get x equals e to the minus 1/2, which is 1 over e to the positive 1/2. And that's not on there. Now, where are they coming up with the negative sign? Could be that our answer is E. I'm thinking for a second. Why can x not be e to the minus 1/2? It can be. That's a positive number, e to the minus 1/2. And in fact, that gives you minus 1/2. However, in other words, what we just came up with, we don't know. I came up with 1 over e to the 1/2, okay? But I don't really know yet whether that is a minimum or a maximum. So let's do the second derivative test to figure out whether it's a minimum or a maximum. So our first derivative was x plus 2x natural log of x. If that's our first derivative, what's our second derivative?
1 plus 2x 1 over x plus 2 natural log x.
Now the question is that plus or minus when e or when x is 1 over, let's see, I can write that as e to the minus 1/2. Now that is 3. This is minus 1/2, so that becomes 3 minus 1 equals 2, which is positive, which opens up. So that's a minimum. What's going on here? You can't blame the teacher for a typo every time I don't get the right answer. Well, let's put this into Wolfram Alpha and see what it has to say. It's the only way I can think of to figure out whether the teacher has made a mistake here. Let's see, x squared natural log of x. X squared natural log of x. takes me forever to find it too. Y equals x squared natural log of x. Now it should give, notice what it's giving us here is the blue is the real part and the orange is the imaginary part. And there's an imaginary part because when you take logs of negative numbers, it's kind of like taking the square root of negative numbers. You get imaginary answers. Same thing with logs, although they don't really teach that to you in high school, but it's true. So our curve is this blue curve right there. So what's the minimum on that? There's two of them. There's one right there. No, but that would require x to be negative. So that one doesn't count. I don't know why their blue curve goes over into that territory. How can x be negative? You can't take the log of a negative number. And hold on a second. That should be natural log, and it put log of x. Oh, it calls it natural log. Okay, that's weird. I'd be inclined to say that's our only answer right there. And that's not a negative number. In fact, can't be a negative number because a negative number would cause the domain to be violated on that function. So I don't know how they have the blue going over to the left of the y-axis. They shouldn't. And as far as where is that, well, let's see. If they give us, usually they give you a lot of derivatives. They do a global minimum, 1 over square root of e. My answer. Notice this. The minimum is minus 1 over 2e. And if I remember right, that was one of the answers on there. What did I do? Close it out? I did. Hold on. Let me open that back up again. Ah. Okay. I get it now. It's not where does the minimum value occur. That wasn't the question. That's what we solve for. When you take the first derivative and set it equal to 0 and solve it, you're finding out where the minimum occurs on the horizontal axis. But if the question says, what is the minimum? Then I take the answer I came up with, which was 1 over square root of e, and plug it in to the function, and it'll tell me what the minimum is. Here, let me do it. It's amazing what the difference between what and where is in calculus. In other words, we found out that the minimum occurs when x equals 1 over e to the 1/2. Okay? So if I plug that in there, then that'll tell me what the minimum is. Well, 1 over e to the 1/2 is 1 over e, and natural log of e to the negative 1/2, which is how I would write that, would be negative 1/2, which gives me negative 1. That's how they get it. My apologies. When I was reading it, I didn't read it closely enough. pull this up a little bit. Well, as a relative minimum at -4, 2, means I have to have points doing that, at least. At a minimum, I got to have a point to the left and the right that is greater than my minimum. I have a relative maximum at -1, 5. And I have a relative minimum at 3, -3. And no other critical points. How many zeros does it have? Well, if I complete this curve, and I don't know that that necessarily has to go to up. You know what I mean? In other words, what keeps that from doing that? And if it does that, then I satisfy the conditions of the problem. I got a relative minimum. That, in other words, that could go all the way up like that. So I have a relative minimum here. I have a relative maximum there. I have a relative minimum there. I do have another relative maximum. And they said no other critical points. That would represent a critical point right there. So the curve must not do this because it would create another critical point, and the curve I suppose that it's theoretically possible that I could draw this thing like this, and it would be asymptotic to the x-axis. The number of zeros is going to be the number of times it crosses the x-axis. So the question is, does this thing have to now cross the x-axis because that's a relative minimum? I don't think it does. In other words, if I were to draw it like this, where it was asymptotic to the x-axis, it would never cross it. I still would have no other critical points, and I only have 1 0. Question is I can also draw this unquestionably like this. And now I have 2 zeros. And I'm inclined to answer that with 2. Just because this would be the most standard way it would look. As opposed to drawing it where it becomes asymptotic with the x-axis. That would be a very strange function. I'm not sure I've ever seen a function that would look quite like that. So I would say 2, but I'm not sure we really know for sure that it's 2 and not 1. It's got to be 1, at least 1 rather, because you cannot get from this maximum to this minimum without going through the x-axis based on the intermediate value theorem. If a function is differentiable and polynomials are, they're continuous and differentiable. That probably is why this thing can't do that, because polynomials don't do that. what does that are things like rational quotients, like 1 over x plus 1 has horizontal asymptotes. Polynomials don't tend to have horizontal asymptotes. So I'm going to go with my 2 as the answer. You don't have answers on these, right? Or do you?
What?
You have
I
answers
do.
on these? You do?
Yeah, I do.
What's number 3? Is it B?
Yep.
Okay. Number 4. The first derivative is given by that. How many critical values does f have on the interval 0 to 10? And the answer is 4 or more. All right, let's see. What's one critical value? Going from 0 to 10. Now, the open interval, not the closed interval, the open interval. It means I don't think 0 counts.
No, it doesn't.
We can't use 0. But what else makes this a critical value? It's whenever sine of 2x is equal to 0, correct?
Uh-huh.
Okay. Well, where does that occur? That occurs when x is 0, which it can't be. But it also occurs when, in other words, the sine is equal to 0 when it's pi. So if x were pi over 2, that's 1, because then I'd be taking the sine of pi, which is equal to 0. And if x were pi, that's another 0.
Would it be 3 pi over 2?
Yep. 3 pi over 2, which is still less than 10. And 2 pi, it's less than 10. And 5 pi over 2, right? Yeah, 5 pi over 2, is that less than 10? Yep. 5 times 3 is 15 divided by 2. And 6 pi, or not 6 pi, 3 pi. That's less than 10. Barely. So we have 1, 2, 3, 4, 5, 6. Is that the answer?
Yep, I would say so.
I mean, on your answer sheet, is C the answer?
Yep.
So we definitely were not able to use x equals 0 as one of them. I guess because it's an open interval. Well, there's another problem with x equals 0. This function is not defined at x equals 0, although that does constitute a critical value. In other words, a critical value is wherever the first derivative is equal to 0 or undefined. Remember, a first derivative can be undefined, and that could be a cusp or something, which could still be a minimum or a maximum. So if 0 was in the interval, had they said from -1 to 10, I think maybe 7, I think x would be a critical value or a critical point. Rather, 0 would be. All right, let's go to the next one. Number 5. Oh, it's continuous on the closed interval and differentiable on the open interval. Now that's interesting. That tells you it's not differentiable at the endpoints. And f of minus 1 is 4, and f of 5 is minus 2. Which of the following statements could be false? Well, let's draw a picture again. From minus 1 to 5, it's continuous and differentiable. And f of minus 1 equals 4, right? In other words, that point is going to be 4. And f of 5 equals minus 2. There's minus 2. So, which of the following statements could be false? There exists a point C on that interval such that f of c is less than or equal to f of x for all x on the closed interval. What the hell does that mean? What they're saying is that which could be false, okay? They're saying that there is some point C on the closed interval, 1 to 5, such that f of c could be less than f of x. In other words, we've got to find a point somewhere below our minus 2 point. Well, that certainly could be true. In other words, if I had a curve that looked like this, if that's my original function, it's certainly continuous on that interval, and it's differentiable on that interval, and f of minus 1 is equal to 4, f of 5 equals minus 2, and the way I've drawn it, this point is C, and f of c is less than f of x throughout the whole interval. So that's possible. But it also could be false. There doesn't have to be a C on that interval. In other words, the graph could have gone like that. And then there is no C where f of c is less than f of x throughout the whole interval. So it seems to me like this could be true or false, which means it could be false, right? It's a weird question. I'm not sure I've seen a question, which of the following statements could be false? Let's just put true or false there. There exists a C on the open interval such that f of c equals 0. Could that be false? No, can't be. The reason is you cannot get from that point to that point without going through the x-axis. You can't skip over it because it's continuous and differentiable on the interval.
Yeah.
There's no way that, I mean, there has to be a C where f of c is equal to 0. So that's definitely true.
Oh, and by the way, I have a booster club meeting where I have to pick up my lacrosse helmet, so I was wondering if I could leave after this problem.
Sure, definitely.
Okay,
There exists a C on that interval such that f prime of C equals 0. That could definitely be false or true. In other words, if I draw it this way, sure, f prime of C is equal to 0 right there. In other words, I have a horizontal tangent line. So it is possible that f prime of C could be equal to 0, but I don't have to have a C that's equal where the derivative is 0. If I draw it this way here, or just draw a straight line from there to there, there's no horizontal tangent line there. So that does not have to be true. That could be true or false, which puts us in a predicament. I may have to have you look this one up also. Let's look at the last two. There exists a C on the open interval so that f of C is equal to 2. That's true. For the same reason that there has to be an f of C equal to 0. I can't get from minus 1 comma, or excuse me, I can't get from f of minus 1, which is up here, to f of 5, which is down there, without going through 2. Again, by the intermediate value theorem. As long as it's continuous, you cannot skip over 2. In other words, there's 2 right there. That function's got to go through 2. So that's always true. There exists such that f prime of C equals minus 1. Well, all that means is the derivative is negative 1 somewhere on there. Aha, that also has to be true. Or does it? Is there a way I can draw that line so that I never have a slope, a negative 1 slope?
I don't think so.
Well, what if I drew it like this? No, as soon as I go down, somewhere along that line, there has to be a slope of negative 1. I can't turn the corner there. I could if I made a cusp, but it's telling us that it's continuous and differentiable on the open interval, so I can't put a cusp in there. So I think this one has to be true, which leaves us 2 possible answers. What's the answer say? Is it A or C?
It says C.
Well, that one definitely could be true or false. But A, I feel like could be true or false also. So they're saying A cannot be false. So A has to be true. I don't understand why. There has to exist a C where f of C would be less than f of x for the whole function. Not the way I've drawn it. If I just draw a straight line like that, there's no f of C that's less than f of x for that whole function. So I'm a little puzzled by that. I don't quite get that. But maybe I'll think about it for a little bit and have an answer for you next Thursday as to this one.
Okay, well, thank you.
You're welcome. Have a good night, Jake. Talk to you Thursday. Bye-bye.
All right. Yeah. I'll see you later.